Hello everyone, welcome back to Math Decoded. Today I'm solving 9709 2016 question paper 1 from May June. So let's get started. So let's have a look at question number 1. It says find the term independent of x in the expansion of this expression. All right, whenever it says independent of x, that means they're talking about the constant term, because a constant term does not have any x in it. And you know that this is a question that will use binomial expansion, so it's very important that you know the formula and the expansion in this question. Basically, if I have a look at this expression, first of all, I will write the first term and I will put it to the power of 6. And you're supposed to know that the first term is going to be 6c0. Then in the second term, you will see that I will put the first term to a power of 5 and this second term to a power of 1. Why? Because this number and this number need to add up to 6. So, and over here we'll have 6c1, over here we will have 6c2, and this is going to be 6c3. I hope that makes sense. Anyways, you can see that across this entire expression, the power of the first term decreases. This is 6, 5, 4, 3, and you can see the power of the second term, it increases. Over here it was 0, over here it's 1, it's 2, and this is 3. I just expanded all of these terms, and you can see that in the fourth term, 6c3 was 20. This was x raised to the power 3, and negative 3 raised to the power 3 is negative 27, and 2 raised to the power 3 is 8. And x raised to the power 3 will obviously be x cubed. So this and this cancels out, and then I just multiplied 20 with negative 27 and divided it by 8, which gives us negative 67.5. So this is basically your answer. You can see that this is a term that is independent of x because it does not have any x term. It is a constant term. Anyways, moving on to question number 2. It says solve the equation 3 sine square theta is equal to 4 cos theta minus 1 for this given range. First of all, you need to know that there are basically two identities that are included in your AS syllabus, which is sine square theta is equal to 1 minus cos square theta, or basically sine square theta plus cos square theta is equal to 1. This is the same thing. And sine theta over cos theta is equal to tan theta. In this question, we're basically going to be using, in order to prevent confusion, I'll just erase this one. In this question, I'm going to be using this one. So I can say that sine square theta is equal to 1 minus cos square theta. So I basically just substituted the identity in instead of in place of this. So this will become 3 bracket 1 minus cos square theta is equal to this exact same thing. Then I started multiplying with the bracket, so that's going to be 3 and minus 3 cos square theta is equal to 4 cos square theta is equal to 4 cos theta minus 1. Now I moved this on this side, that makes it positive, and you get this quadratic equation. Over here I can say that cos theta is equal to any variable. I put it equal to m. This means 3m square plus 4m minus 4 is equal to 0. You need to show these steps, otherwise you will not get the mark for this quadratic equation. These steps need to be shown. Either you can do it by middle term breaking, or you can do it by this quadratic formula. Anyways, when you basically put this into your calculator to solve it, you will get two values, 2 over 3 and negative 2. Negative 2 is obviously going to be rejected because m is actually equal to cos theta, and cos inverse of negative 2 does not exist over here, so this is going to be rejected. This value obviously exists, and you basically, the first term that you will get is 48.189 in the first quadrant. Now, for the quadrants, you need to understand that this is all positive, sine positive, tan positive, and this is cos positive. In this case, we had cos as positive, which basically means that you will look at this quadrant and this quadrant, and they're basically separate formulas for each quadrant. In this case, in the first quadrant, your answer is just x. In the second quadrant, your answer is 180 minus x. In this quadrant, it's 180 plus x. And in this case, it's 360 minus x. You can basically memorize these. That makes it much easier. And that's how I do it as well. Anyway, so the first answer over here is going to be x, which is basically 48.189. And the second one is going to be found out by doing 360 minus 48.189. This quadrant basically. You need to understand that angles always need to be given to one decimal place. Therefore, I rounded off both of the answers to one decimal place. I hope that makes sense. Anyways, moving on to question number 3, it says the diagram shows part of the curve x is equal to 12 over y square minus 12. The shaded region is bound by the curve and the y-axis and the lines y is equal to 1 and y is equal to 2. Showing all necessary working, find the volume in terms of pi when this shaded region is rotated through 360 degree about the y-axis. Alright, now first of all, you need to see that in this question, they have given you the limits on the y-axis. And over here, I've made this note as well that whenever your limits are on the y-axis, it means that x is supposed to be the subject of your formula, not y, which is something that they have done for you in this question. Anyways, I'm going to use the basic formula. So the volume of rotation is equal to pi into the integral of your expression. And so basically, I'm just going to plug in this expression over here. If I write it down like this, I'm just going to use the identity over here, which is a square minus 2ab plus b square. So this is your a and this is your b. This is what I did over here. A square minus 2ab plus b square. Basically, I then just integrated all of these things. I moved this expression in the numerator, so that becomes 144 multiplied by y raised to power negative 4, 48 multiplied by y raised to power negative 2, and 4 just remains as it is. And do not forget to put this pi outside, otherwise a mark will be deducted. Anyways, basically then what you do is that you increase you basically add 1 to this power, that makes it negative 3, and you divide the new power in the numerator, and that is what I did over here as well. Similarly, I did that over here, and you know that a constant term just has the variable multiplied with it. Anyways, I know that the limits in this case are 2 and 1, so first I put in 2 and then I put in 2 and then I put in the second limit, that was 1, and I subtracted both the expressions. This gives us 26 pi, this gives us 4 pi, and the final answer then comes out to be 22 pi. You can also write this down in decimal, but I preferred to give the exact answer. That's just always better. Alright, moving on to question number 4, it says a curve is such that dy by dx is equal to this expression. A point P moves along the curve in such a way that the x coordinate is increasing at a constant rate of 0.3 units. Alright, whenever it talks about rate, it means that you're going to be dividing something by time. In this case, it's the x coordinate, so I'll say dx by dt is equal to 0.3 because 0.3 is given to us in the question. Anyways, then it says find the rate of rate. Again, it says rate. So there's something related to time again. Rate of change of the y coordinate as P crosses the y-axis. Now, you need to understand whenever something is crossing the y-axis, the x coordinate at that point is supposed to be 0. They're basically telling you to find out dy by dt because it's y coordinate and it says rate. So dy by dt is something that you're supposed to be finding. Now, in these type of questions, it's very important that you first make an equation so you can figure out what information you have and what information you need to figure out. So, dy by dt is something I need to find out. I'll put dy over here, dt over here, and I'll fill in the remaining spaces with the other variable in this question, which is dx. This is your equation. Now, in this question, we already have this given to us, which is 0.3, and this is something we need to figure out. Now, I know that dy by dx has an equation in the question. What I'm basically going to do is that I'm going to plug in 0 into this exact expression because we need to find a numerical value for this expression. So when I put in 0, that gives me the value of negative 2. I will multiply negative 2 with 0.3, and that gives us the answer for the first part as negative 0.6. Alright, moving on to the next question, it says the curve intersects the y-axis where y is equal to 4 over 3. Now, you need to understand whenever something is intersecting the y-axis, as I said before as well, x coordinate is supposed to be 0. So this gives us one coordinate, 0, 4 over 3. It says find the equation of the curve. Now, whenever you're going from y to dy by dx, you need to understand in this case you're supposed to differentiate it. But if you're going from dy by dx to y, you're supposed to integrate it. In this question, we have dy by dx given to us and they're telling you to go to y, which basically means you'll have to integrate this expression. Anyways, so I wrote it down over here. I can separate these two things, so integral of 2 and then the integral of this entire expression, which I did over here. When I integrated, this becomes 2x. In this case, I will apply the chain rule. I will increase this power by 1 and I will divide it by the increased power over here, and I will also divide it by the inner differentiation of this bracket, which is basically 3. This gives us this expression, and you need to understand whenever you're integrating something that is not a definite integral, you will also put plus c over there. Now, how do I figure out the value of c? I have one coordinate which is 0, 4 over 3. So I plugged in x as 0 and y as 4 over 3 to figure out the value of c. When I do some basic algebra, move things around, I will get the value of c as 12. And this gives us our final expression that is written over here. So this entire expression that was integrated along with plus c, that was plus 12. Alright, moving on to question number 5. It says a farmer divides a rectangular piece of land into 8 equal sized rectangular sheep pens as shown in the diagram. This is the diagram. Each sheep pen measures x meter by y meter and is fully enclosed by a metal fencing. The farmer uses 480 meter of fencing. This basically means you'll have to make some equation using this numerical. Show that the total area of land used for the sheep pens is given by this equation. Now you can see that in this equation you don't have any y. There's no y variable involved in this question, in this equation. So first of all, let's talk about area. I know that not one actually. I can say that this total length is 1, 2, 3, 4x. And I can say that this total length is 2y. And I know that the area of a rectangle is basically 4x into 2y. That's going to give me 8xy, which is something I have written down over here. Now, the problem is that you do not need this y to get rid of this. How do I get rid of this? I will have to make some equation where y is the subject of the formula. Now, if I have a look at this number, how can I make an equation out of this? It basically means that the farmer used this much material for fencing. How am I going to do the fencing? I can say that this is x, and how many such lengths do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That makes it 12x. Similarly, for y meters, I need to cover these pink lengths, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10y. Now I can add both of these up and put it equal to 480. And this is what I did over here. After that, I basically took 2 common out and I divided it over here with 480. This makes it 6x plus 5y is equal to 240. And from here, I can make y the subject of the formula. And I can substitute this expression over here. When I do that, it leaves me with this. And then I divide both of these numbers by 5 to get this expression, which is exactly the same as the one that we were asked to show. So part 1 is done. Let's have a look at part 2. It says, given that x and y can vary, find the dimensions of each sheep pen. Now, where it says dimensions, it means you need to find y and x both. So, it says sheep pen for which the value of a is a maximum. Whenever it says maximum, it means that the derivative is probably equal to 0. And we have this equation. If I find out the derivative of this, I need to put it equal to 0. So similarly, in this question, I know that constants are just for this it's just gonna become a constant, and for this expression I'm going to multiply 9.6 with 2, and I'm going to reduce the power by 1, which gives us this expression. I'm going to put this equal to 0 and get the value of x as 20. Then I'm going to substitute this value of 20 into this equation over here, which I've done over here as well. That gives us the value of y as 24. I need to find both x and y because it said dimensions. Right, moving on to question number 9. It says the first term of a geometric progression in which all the terms are positive is 50. So the first term is given to you. The third term is 32. Find the sum to infinity of the progression. Okay, so basically, first of all, this is a geometric progression. You'll have to make an equation, which is basically going to be u3 is equal to u1 into r square. The trick I use to make these equations is that and you need to make sure that this number and this number are adding up to this number 3 in this case. So I know that the third term is 32, the first term is 50, so this will give me a value for r square that I can further simplify to get a value for the ratio, that is 4 over 5. Now that I have this, I can simply plug it into this formula, which is the sum to infinity for a geometric progression, that is first term divided by 1 minus r. First term is 50, r is something we just found out, that is 4 by 5. So I get the value for sum to infinity, that is 250. Moving on to part B, it says that the first 3 terms of an arithmetic progression are this, this, and this, where x is an acute angle. The first part says show that tan x is equal to 4 over 3. Now, first of all, you need to understand that in an arithmetic progression, the difference between this term and this term is going to be equal to the difference between this term and this term. So you basically have to subtract each of them, which is something I've done over here. You basically move like terms to one side, and this will give you this equation, and then you basically divide sine x by cos x. That's going to give you tan x, which is going to be tan x is equal to 4 over 3, and which is exactly what we had to show in the first part. The second part says find the sum of the first 20 terms of the progression. Now basically, when you have tan x, you can also figure out sine x and cos x using your calculator, and using that you can write down the first term, rewrite the first term, second term, and the third term, which I did over here. And now I can say that the difference over here is 1 by 5. How do I know that? It was an arithmetic progression, so I subtract this from this to get the difference. And then I use the formula for the sum of the first 20 terms, which I have over here, which is 20 by 2, 2 into the first term plus the difference into 20 minus 1, that was 19. And that gives me the answer as the sum of the first 20 terms as 70. Question number 10 is something that I have skipped because it was related to vectors, which are no longer part of your AS syllabus. So moving on to question number 11. It says that the function f is defined by this expression for this particular range. State the range of f. So finding the range is very simple. You basically first of all going to plug in this, then you're going to plug in this. You will get 2 separate answers that are going to make up your range. So when I plugged in half pi, that gives us 3, and when I plugged in negative half pi, that gives us negative 5. So I just stated the range over here. Then it says find the coordinates of the points at which the curve y equals f of x intersects the coordinate axes. Now the coordinate axes are basically the x-axis and the y-axis. And you know, at the x-axis your y is equal to 0, and at the y-axis your x is equal to 0. So that's what I did. One by one, first I put y as 0. In the next part I put x as 0, and this gives us over here you just get one coordinate, but over here you will have to take the inverse of sine inverse of 1 over 4. And remember that this question is in radians because you had pi over here. So when you're doing this calculation, your calculator must be in radians. So this gives you this coordinate and this coordinate. The next part says sketch the graph of y equals f of x. Now you need to understand one thing. This is your equation. You need to understand that this part is your mean axis, the average part where the graph lies. So basically that means is the middle of my graph is -1, and 4 means that the maximum and the minimum amplitude is going to be -1 plus 4 and -1 minus 4, which basically means that the highest point is going to be at 3 and the lowest point is going to be at -5, which are 2 points that I've already marked over here. So you know that a sine graph exists in this shape, and this is what I will be drawing over here. Just remember that you have to limit it to this range, nothing beyond or nothing less than this. And yes, do not forget to mark the axes with these numbers, these carry marks. Anyways, the last part says obtain an expression for f inverse of x, stating the domain and the range of f inverse. So basically, when you're finding the inverse, you first of all are going to replace the y with the x's and the x's with the y's, which is something I did over here. And after that you have to make y the subject of the formula. So basically I isolated sine y over here, then I took sine inverse on that side, and y was now the subject of the formula. Then I replace this with f inverse of x. This gives me the expression for the inverse. You need to remember one thing, that the domain of f inverse is equal to the range of f of x, and vice versa. So range of f inverse of x is equal to the domain of f of x. This is a rule. You should memorize this if you do not know this already. So this similar thing I've done over here. This is f inverse of x. The range of this is going to be the domain of f of x. The domain of f of x was this mentioned in the question, and we found the domain of this is going to be the range of f of x. The range of f of x was something that we found in the very first part, which was this, and I've exactly copied this down over here. So this brings us to the end of this paper. I hope that this was helpful for you, and feel free to ask any questions down in the comments.